Hi everyone, I am Umut and I am an Unreal authorized instructor and a senior developer. If you have been working with Unreal Engine for a while, you know that optimization is not just about making things run fast. It's about keeping your sanity intact. We have all been there, right? You have a beautiful scene and the lighting is perfect, the assets are high quality, but the FPS is dropping. And the profiler looks like a heart attack monitor. Usually we blame the polygon count or the lights, but today I want to show you the silent killers. In this video, we are going to dive deep into Stackobot project to uncover three specific performance traps that often go unnoticed. First of all, the memory killer. How a single cast node can silently bloat your memory usage. The second one, the CPU hiccup. Understanding the garbage collection hitches and how to fix them with object pooling. The third one, the invisible load. Why objects you can't see might still be eating up your frame rate. By the end of this session, you'll have a solid understanding of how to use tools like SizeMap, Reference Viewer, and console commands to hunt down these issues. So grab your coffee, fire up the engine, and let's get started. Welcome to the lab. Okay, today our patient is the famous Stackobot project by Epic Games. It's a fantastic example of vertical slice. It has everything, high quality meshes, complex shader, and Niagara particles. Yeah, everything. Visually, it looks production ready, right? And when we go looking at the project, we see that everything is great, right? And let's look at the content browser. In content browser, at first you will see three top folders, which are devcom, splash, and stackobot. I added these two folders. I created proflab and I added scene banked assets to demonstrate the relationship between memory and the hard references. So everything seems pretty perfectly organized, right? You might just look at it and say, yeah, this project is clean, nothing to fix here. But we know better. Clean folders can hide dirty references. Okay, let's take a spin. So I will press the play button and test it. I can collect the coins. Everything is smooth. We have good tooltips. We have very good vertical slice, right? We have all sorts of mechanics, etc. Okay, but as you already know, uh, optimization isn't about does it work. It's about at what cost. Right now, I will add, I added somewhere there. Let me find it. Okay, it's here. Small tiny robot, right? This simple robot might be carrying invisible weights that are silently killing our performance. Okay, we don't feel it on this powerful PC yet, but a console, a mobile phone, or low-end or mid-end devices, they will be screaming. So let's stop looking at the surface and start looking at the data. Let's hunt down our first suspect, which is memory bloat. Okay, Alright, let's talk about memory. And uh, imagine you are going on a hiking trip, right? You pack your backpack with essentials like water, a map, maybe a snack. And that makes sense, right? But what if just by putting a photo of your grand piano in your pocket, you were magically forced to carry the actual 500-kilogram piano on your back? That sounds ridiculous, right? But in Unreal Engine, we do this all the time without realizing it. We call this a hard reference. Now, let's translate this invisible piano into game development terms. Why is this a disaster? It actually hits you in two places. First, RAM usage, which is memory bloat. The second one is loading hitches. About RAM usage, even if you don't see the heavy asset, it sits in your RAM, eating up your space. It pushes out useful textures and limits what else you can load. The second one, yeah, this is maybe more importantly, when you spawn this simple character, the engine pauses the game to read that heavy asset from disk. That split-second freeze when you open a menu or spawn something, you can understand what I mean, right? That is usually a hard reference stopping the show. We are paying a heavy tax for something that we aren't even using. Now you might think, but I didn't put a piano in there. I just made a simple character. But here is the harsh truth. Unreal Engine doesn't care about your intentions. It cares about your links. In a professional studio, we never assume a blueprint is lightweight just because it looks simple. We verify. Before I say I am done with this character, I have to weigh its backpack. If I don't, I might actually break the game's memory budget. So let's put our friend bot on the scale. Okay, so let me show you exactly what I mean. Here is our friendly Stackobot character. It looks small, lightweight. But let's investigate it further. Like, you can click on Edit Blueprint in the World Outliner, or you can search for its name. So let's click the Edit Blueprint, and so let's find the asset location by clicking the magnifier icon. Here's bp.npc character that I have created. So right click and let's look for size map. If you look at it, we have 3 gigabytes, exactly 3.2 gigabytes of the disk size. And if I switch to memory, it's also high, but the disk size is showing the referenced assets by our Stackobot character. Let's look at them in details. For example, BP heavy payload. BP heavy payload, what is it? Let's search for it. You can read, right? BP heavy payload. So BP heavy. Okay, there is no asset in this world. It is not in the level even. It is not spawned. It is just sitting in the memory. It is just sitting there. So why is it loaded into memory? Why is it referenced? Because somewhere in our bot's blueprint, let's look at the parent BP, bot MPC heavy. So may have used cast to node or used a hard object reference variable. So before moving to the blueprints, so let's try to clear the topic about the hard references. Okay? So here is the golden rule of Unreal Memory Management. If asset A references asset B, loading A will always load B. So when the game starts and spawns player, the engine sees that cast to node and says, hey, the player might need this heavy boss asset later. So I better load the entire boss or entire heavy asset, his textures, his sounds, his animations into RAM right now. Even if you never meet that boss, you are paying the memory cost for it. Uh, this is how mobile games crash or PC games stutter because of loading hitches, you know? So what is the solution? We have two ways, right? How do we fix this? So we should ask how do we carry the photograph without the grand piano? You remember the analogy, right? We have two main tools. First one, soft object reference, which means instead of a direct link, which is hard reference, we use a string path, which is a soft link. The engine only loads it when we specifically tell it to. So the second one is interface. This is my favorite. Instead of casting to a specific class, we just send a blind message. So we are sending the message and we hope that, we won't hope, but I will explain later. It will reach the target. Okay, so start investigating further. Okay, so let's start with the blueprints of the bot NPC heavy. We know that there's some Chester node or hard references here, so let's look at it. And yeah, most probably at the beginning or prototyping, you tend to use Chester nodes on begin overlaps because it's fast, right? But this is like a toxic relationship. My character actually doesn't need to know this BP heavy payload to start the party from the event of this heavy payload, right? So instead of using this cast node, first let's delete this cast. I can use another approach that I have talked about, which is, let me delete it and recompile it. So let's look at the size map again. BPBot heavy size map. You see, right? Disk size. It is. It was 3 GB. You know. It is now 65 megabytes. It should be something like that, around that number. So we have talked about interfaces. Instead of using the cast node, I will use a blueprint interface. So let's right click in the content browser and in the blueprint menu, I will choose blueprint interface. So let's give it a good name like BPI game events, for example. Let's save it and open the blueprint interface. So I am trying to starting a party, right? In the blueprint interface menu, I will add a new interface function, which is called start party. Start the party, start party. Okay. You can add inputs and outputs to the interface from the bottom right menu. You can add description, keywords, etc. So let's compile and save. Close this menu. We have created our first interface. Let's open bpbot MPC. If we overlap with the actor that has tag building banquet, then I will call this interface, which is start party. If you see, we have created BPI game events and start party message. Let's look at the tooltip. Message means this does nothing if the target does not implement the required interface. We need the target that we are calling interface for, the other actor. We can change our control. If other actor implementing the interface, uh, interface. Okay, let's find the required function. It's not that, but okay, let's search again. Okay, I have found the correct one. Sorry for the delay. Then does object implement interface checks if the given object implements a specific interface. If our logic relies on it, uh, we should, for example, it returns something, right? Boolean, true or false. We doesn't rely the default value of the return value, default of the return value, right? We should be mm, we should know if this object implements interface or not. Okay, so let's search our event, which is BPI game events, right? Okay, does object implement interface? If it implements, then we can start the party. So I have sent the message right now. Let me summarize this. Instead of casting, I will first verify that the object implements this interface. Then if yes, I call the interface. Does it ask for our our have a payload? Like, did you remember the chest heavy payload, right? Our interface isn't asking this heavy payload. It is just ask for the target actor. So if it implements the interface, then it calls it. So let's go to the sorry. So let's go to the our MPC, bot MPC heavy. Then, sorry. Uh, let's go to our heavy payload. And in the class settings, yes, we will add our new interface. We will implement our new interface. So for implemented interfaces, we will add our newly created interface, BPI, game, events. And as soon as I implemented the interface, when we look at the left hand side, we see start party. Let's double click on it. So you will see the interface. Let's copy this print string and paste it. Party started. Compile and save. As soon as we call the interface, the party started event will be fired. So to demonstrate it quickly, I will try to demonstrate its effect. I will right click on the bot MPC heavy and look for the size map. Look, it's still 65 megabytes. So our memory is clean and there is no hard references here. The other way that we have talked about is the soft references. If you look at the optimized version that I have created earlier, you can still cast, though it still creates hard reference dependency, you can use the array of static meshes or other type of objects as soft object reference. Soft object reference means that you only have the address. You can load them later on. So in your logic, you can call this array or this object and get a copy of it and call load asset blocking for synchronous operations and call async load asset for asynchronous loading operation. Then you have the actual object that you can work on. Yeah, it's right. It's like that. Now that our memory is clean, let's look at another silent killer. This one doesn't eat your RAM, doesn't reside on your RAM constantly, but it eats your CPU cycles. And it really loves to hide in the plain sight. Okay, now let's move from memory to the CPU. Imagine you invite friends over for a dinner. You eat and you drink, and when you are done, you smash your porcelain plate on the floor and go buy a new one for dessert. That sounds insane, right? Expensive and messy. But in game development, we do this constantly with projectiles, particles, and enemy spawns, etc. We call it spawn and destroy. And just like in real life, someone has to clean up that mess. In Unreal, that someone is the garbage collector. Okay, so let's look at this turret. I have modified it for a stress test. It is not just firing rapidly. Inside the blueprint, For every tick, it is it is spawning 20 actors of bullets. If your game is 60 FPS, it means 1200 bullets. Uh, Visually, it looks like a particle effect, but it is chaos. Let's simulate the game or play the game if you want. Let's make it start with tick enabled. So let's simulate. Okay. And oh, sorry, I forgot the one thing. Let's make the bullets disappear after 1 second so that my setup is creating the bullets, spawning the bullets, making it going forward with the projectile movement and then destroying them after 1 second for their initial life with their initial lifespan. Okay, so let's simulate again. You see, we are constantly spawning and it is changing according to the frame rate, which is also bad. We're trying to spawn bullets every time. And let's enter the console command while game is running, which is stat game. Stat game. So can you see these red lines that is constantly uh, almost going popping out of the world tick time, and spawn time is also so high at the fourth place. So when the RAM is full or when the garbage collector gets the place, the destroy actor will also increase, and we have terrible milliseconds for just one turret firing bullets. So let's stop the game and turn our logic. Let me tell you something. Here is the reality. Spawning actor is expensive, and destroying an actor is even more expensive. When you call destroy actor, the memory isn't freed immediately. It is marked as garbage. And let me visualize it. Destroy actor. Nah, I'm talking about this. So when the pile, as I said, the memory isn't read immediately, uh, it is marked as garbage. We are telling the engine that this object is garbage. So when the pile of garbage gets big enough, the GC, which is garbage collector, pauses everything, physics, rendering, logic, to sweep it away. If you are doing this every frame, you are basically DDoSing your own CPU. So, what is the solution? The solution is object pooling. Let me disable start with tick enabled, so this won't play, this won't execute at the start of the game. And open the other blueprint. Let's start with tick enabled. The object pooling method is simple. Don't destroy. Just like you wash your plate after having dinner for desserts, and put it back or put it back in the cupboard, we should recycle our actors. We call this object pooling. But be careful. Just hiding the actor is not enough. Instead of destroying actor on impact or giving them the initial lifespan, we will do this. 3 operations. Inside the bullet, before sending the actor to the pool, we will first set actor hidden in game to stop drawing pixels, right? Set actor enable collision false to stop calculating hits, and we will deactivate the projectile movement, which is for stop updating location. So this object, this bullet, BP bullet, is now ready to be sent in the pool. And when the turret needs to fire again, we won't spawn it. We just grab hidden bullet from our pool and move it to the barrel and turn it back on. The result, zero garbage, zero spikes, pure smooth performance. Not pure smooth for this example, but we will have especially zero garbage. Okay, so in the fire bullet function, we will start firing it. We will start using the bullet again. So we need, as I said, the starting position of this bullet. So we will set the actor location. We will teleport the object. We are not caring if it is caring about its path. It is the way that it is coming. We are just teleporting it. Okay, and we will start drawing pixels again. We will enable collision, and we will activate the projectile movement. So it is ready to be fired. We will set the velocity of projectile movement component. After that, do you remember we have set the initial lifespan of a bullet? We won't do this because we are using this actor again. We don't want it to be destroyed immediately after 1 second. Okay, so let it be 0. 0 means infinite. So after 1 second, we will reset this bullet. Deactivate bullet. Deactivate bullet, what was it? Stop drawing pixels, stop calculating hits, stop updating location. So that we have created a loop for our objects. We have created a pool that they can reside in. So in BP turret, I have same logic for every frame. I have for loop. I don't say this is the best way, but to compare these two examples equally, I have created the same logic. Instead, I am not spawning every bullet. I am just getting the first bullet. Oh, sorry. I am just getting the first bullet from the bullet pool. I call fire bullet function, which was, the setting transform, enable collision, etc. I increase the index of current pool index. Currently, I have 400 objects, 400 actors in my bullet pool object. So if my current pool index is greater or equal than 400, so we will reset the current pool index. You see, it is the same logic, same simple pool. We are using event tick, but we have changed our logic to use pool. So let's test this example and see the difference. Let's see BP turret optimized and okay. Let me hide everyone and turn on BP turret optimized. So when I hit simulate again, you see the difference. It is more than half of the first bad example, yeah? Tick time is still high, but you see spawn time is zero because we have spawned all 400 bullets at the beginning of the game. We don't have spam actors also. We don't have destroy actors. Everyone is clean. Everyone is smooth because we are not spawning and destroying. We are reusing our bullets. So let me show you this one too. At the beginning, yep, we are creating 400 of bullets and adding them to our pool. So deactivate them. That is the basics of object pooling, and that is why they are important for memory management, for CPU management, for CPU management. And you may ask, wait, we are using hard references here. Didn't you say using the load reference was better? This is a good question. But here, the turret optimized, needs the bullets immediately to work. So they are not in a toxic relationship. They need each other. They are partners. Pooling requires instant access. We should be able to instantly access the bullet in this pool. So we keep these bullets loaded in memory, which is hard reference. So remember this. Optimization is about managing memory, not just emptying it. So remember, reduce, reuse, and recycle. Your CPU will surely thank you. And now, speaking of invisible things, let's talk about our final suspect, the one that works hard even when no one is watching. Okay, finally, let's talk about the invisible load. Imagine you leave your house for a vacation or something, yeah? You turn off the lights, you lock the door, and leave. But you leave the TV running, the washing machine spinning, and the shower on. Nobody's watching the TV, nobody's using shower, but the electricity bill is still skyrocketing. In Unreal Engine, we call these vampire actors. They suck your performance dry, even when you can't see them. Let's see them in example, so that let's hop into the Unreal Engine. Okay, now let's look at my screen. I am staring a blank wall. This big. I'm talking about this big wall, but uh, our game isn't smooth at all. Let's write some console commands like stat unit, and I see that my game thread is really high, like 28 ms. So let's look at for. By the way, you generally look for game and drop thread, and which is higher, that is your bottleneck. That is the general rule. Generally, you can follow these aspects, and so We have decided that the game rate is really high. So let's write a console command to investigate it further. Stats game. Okay, we have world tick time, which is really high. Tick time, blueprint time. So let's look at the behind of this wall. Oh, there are so many coins flipping around here, but I cannot see them. I cannot even see them. So my draw thread is not rendering it. Because what is the cause? So the another approach you can find these hidden ticks like sorry and clear log. You can type in dump ticks, dump ticks, enter. It will list all the actors that is currently ticking in the world. Let's stop the game. And world tick time is going down, as you see. So let's try to look at, and there are lots of BP coin here, right? BP, and other actors that is currently ticking they are currently ticking, and BP coin again, BP spinning coin, BP spinning coin. It is crazy. Hi, BP spinning. What is this BP spinning coin? So let's copy this blueprint name and paste it here. So BP spinning coin. Okay, where is it? Let's click the actor and press the F so we can't go because they are not loaded yet. So let's right click on the folder and force load for now. Okay, spinning coins here, but let me demonstrate it again by pressing play button. I cannot see them. They don't need to. Uh, they don't need to tick. They. I don't care what they are doing it right now because I am not interacting with them. They're just coin spinning behind the wall. So at least that is what your GPU thinks. I can see them. I can. Why I am still rendering it? So let's not render it. Yeah, that is why GPU says. But your CPU is still running their eventic, calculating their rotation, their math, their logic according to FPS. If it is 60 FPS game, 60 frames per second for no reason. So how do we kill a vampire actor? We tell it if nobody sees you or nobody will interact with you anytime soon. So go to sleep, right? Let's press the escape button and write the commands again to clearly see the world. Stat, game. Okay, sorry. Then in a real production, we use significance manager. But that is whole another topic, so that I will give you an idea. I will give you an overview of how we can optimize these kind of issues. So we have spinning coin here, right? Let's open the blueprint and here actor rotation, currently ticking, currently executing this logic. But we have very good approach here. Was actor recently sorry, was actor recently rendered? Okay, first of all, let's demonstrate if this works. So I am clicking the actor, and in the search panel I will search for tick. Okay, start with tick enabled. I will turn this off, and I will look at the static game and game thread in milliseconds. Let's play. And let's open stat game. You can see the difference, right? World tick time, blueprint time, they are all long. And so that it is not a bottleneck anymore. So they are ticking even we don't interact with them. So let's create a logic of this. If this actor, this spinning coin, was not recently rendered, then set actor tick enabled to false. If it is rendered, set actor tick enabled is true. So we are checking visibility every 0.2 seconds by set timer by event. In fact, we are starting with set actor tick enabled as false. It is not ticking currently. So let's use begin play event to execute this function. So, okay. So here we expect it not to be rendered when we are not looking at it, right? So come back to level Stackobot and press play. Well, look at world tick time. It's just ticking and it didn't work. But if we turn around a bit, like looking the exact opposite, it is not rendering, right? But if I look at it again, look through the wall again, it is ticking. But why? I can't see them. Actually, you are wrong, right? Let me tell you one thing. If the shadow of this static mesh is visible in the scene, visible by the camera, if shadow of this coin static mesh is visible by the camera, then it will be rendered. For the shadow that pass, the original mass should be or original static mesh should be calculated according to these shadows. So even if you see shadows, it means this actor is recently rendered. So let's do one more thing. And let me explain it later. I will disable the cast shadow tick of this static mesh coin. So if you cannot disable the shadow like large buildings, like characters, so that you can use another approach of calculating the distance between player and this building or character. There are lots of other approaches, but In terms of simplicity, I will go with was recently rendered, was active recently rendered node. So I have disabled cast shadow. I will go back to level Stackobot optimize project. I will click play optimization lab. So look at the world tick time right now. And it is very smooth. Yeah. But if I go near this wall and start looking at coins, yeah, they are ticking right now. Look at the tick time, look at the blueprint time, world tick time. And when I stop looking at them, yeah, I can see their shadows, I can see their meshes, so their tick is disabled. So I want to clear one thing. You can ask, if we are disabling the tick, disabling the brain, the execution flow of this actor, how can it execute this timer function? Okay. The answer is timers are executed in world. They are not executed in actors. They are not bound to actors. Timers are executed within the world, within the level, so that we can do this check even if actor tick is disabled. Okay, so there you have it. First, we stopped carrying the grand piano. We have get rid of hard references. We have learned the subject of soft references. We have implemented custom interface, and we have implemented the logic about talking with from one actor to another without knowing the actor with interfaces. So, second one, we stopped smashing plates, GC thrashing, right? After every meal, we don't just hold the plate and throw it on the wall. We have learned the terminology method of reusing, object pooling. We have defined object pool. We have looked for reactivation our actor. We have found a way to reuse it before without destroying it and spamming again. So we killed the vampires. We killed. We stopped the logics of hidden actors that is not currently seen from the camera. So, which is tick optimization, and we have talked about the significance manager. You can search for it if you want. But we just used was recently rendered, and we talked about the shadow pass. We have talked about the shadows of objects and how they can be rendered on the camera. So how it can affect the currently rendered property of the object, right? So as you have understood, the optimization is not magic. It is just good housekeeping. You are not blindly emptying the memory. You are keeping what you currently need, what you will need in the near future, not the distant future, yeah, in the very far future. If you enjoyed this deep dive, let me know. I am Umut, and I'll see you in the next one. Happy coding, hopefully.